Hi everyone, welcome back to ANR Academy. This is Nepaledi sir. Today I am here with you to discuss 5 special concepts from the topic inequalities. This is first one, a square plus b square divided by a plus b, which is greater than or equal to average of a plus b. Second one, a power 4 plus b power 4 divided by a power 2 plus b power 2, which is always greater than or equal to average of a square plus b square. Third one, a power 3 plus b power 3 divided by a plus b, which is greater than or equal to ab. And here the condition, at a time both ab non-zero quantities. Why? Because a plus b in denominator part. Here also, at a time a square plus b square non-zero quantities. Here at a time a and b both non-zero quantities, remember. Next, root over x square plus y square plus root over a square plus b square greater than or equal to root over x plus a whole square plus y plus b whole square. Next, a plus b plus c by 3 whole square, which is always greater than or equal to 1/3 ab plus bc plus ca. Let us prove all the results. See first one. You have a square plus b square divided by a plus b. To prove this, I am going to select let us suppose a minus b whole square. Square quantity always non-negative. So I can write the inequality greater than or equal to 0. On expansion it become a square plus b square minus 2 times of ab, which is greater than or equal to 0. From this I can write a square plus b square greater than or equal to 2 times of ab. Next, both the sides I am going to add a square plus b square. Already you have a square plus b square, for which the same quantity we are going to add. So that here in the right part also you have to add the same. Next, left hand side it become 2 times of a square plus b square, which is greater than or equal to a plus b whole square. Now divide both the sides with 2 times of a plus b, you will get the result. Here a plus b more than 0. What happens? Observe. A square plus b square whole divided by a plus b, which is greater than or equal to half of a plus b. That's all. Next, a power 4 plus b power 4 divided by a square plus b square you have in the left part. So to prove this, let us suppose a square minus b square whole square, which is non-negative square quantity. Now expand this. A power 4 plus b power 4 minus 2 times of a square b square, which is greater than or equal to 0. A power 4 plus b power 4 greater than or equal to 2 times of a square b square. Next, what I am doing, same quantity if you add, you will get left side 2 times of a square plus b square. The same a square plus b power a power 4 plus b power 4 left side as well as right side I am going to add. Just added a power 4 plus b power 4 on both the sides. So it become double, and right hand side that can be written as perfect square. That is a square plus b square whole square. This is 2 times of a power 4 plus b power 4. Next, when you divide with 2 times of a square plus b square on both the sides. you will get the above inequality, that is a power 4 plus b power 4, which is greater than or equal to half of a square plus b square. Hence the second result proved. Next, see third one. To prove this, let us suppose square of a minus b, which is non-negative, and from this I can write a square plus b square greater than or equal to 2ab. A square plus b square, 1ab here itself, and one more ab in the right part I am writing. There are 2 times ab in the right part. Transfer 1ab into the left, you will get this result, and I can write this as a square minus ab plus b square greater than or equal to ab. Both the sides, if you multiply with a plus b, what happens? Observe. A plus b multiplied by a square minus ab plus b square, and here it is a plus b multiplied by ab. Clearly, a plus b into a square minus ab plus b square written as a power 3 plus b power 3. So it is greater than or equal to a plus b of ab. Dividing both the sides with a plus b, then you will get the inequality, that is a cube plus b cube divided by a plus b, which is greater than or equal to ab. So hence the third result proved. Next, see this, root over x square plus y square plus root over a square plus b square greater than or equal to root over x plus a whole square plus y plus b whole square is there. Let us suppose a square quantity of bx minus ay, which is non-negative. Square quantity always non-negative. To prove this, first I am going to select bx minus ay whole square. Now on expansion it is b square x square plus a square y square greater than or equal to 2ab xy, I can write. Next, b square x square plus a square y square as it is. Now what I am doing, observe, both the sides, if you add b square y square plus a square x square, here b square y square plus a square x square I am going to add on both the sides. Then it become, here x square is common term. If you take x square common from first and last terms, you will get a square plus b square inside, and from the middle terms, if you take common y square, and inside we get a square plus b square. So I can write this as a square plus b square of x square plus y square, which is greater than or equal to, and it can be written as perfect square, that is ax plus by whole square. Apply square on both the sides, square root on both the sides, square root here and here. Already internal quantities are positive, so there is no change in the inequality, remember, and it become root over a square plus b square, it is root over x square plus y square, and this is ax plus by. Now multiply with 2 on both the sides. Here 1 2 and here 1 2 I am going to write. Then there is no change in the inequality. In the next step, what I am doing, observe, both the sides if you write x square plus y square plus a square plus b square, adding this term we get 2 times of a square plus b square here multiplied by root over x square plus y square, which is greater than or equal to both the sides. What we are doing, adding x square plus y square plus a square plus b square, and you have 2ax 2by. Here it is 2ax plus 2by. Now I can write this as root square, here square root and square. It looks like a square plus b square plus 2ab model, so that it is a plus b root over x square plus y square root over a square plus b square whole square I can write. Yes. Next, in the right hand side it become x square a square 2ax combination a plus x or x plus a whole square. Remaining 3 terms you can write b plus y whole square. Now in the last step, neglecting square, that is applying power 1 by 2 on both the sides, you will get x square plus y square plus root over a square plus b square, which is greater than or equal to root over x plus a whole square plus b plus y whole square. And the proof is very difficult, but you can easily remember by basic triangular property. You know that sum of two sides always greater than the third side. Suppose that here there is a point whose coordinates x comma y, and assume that here a point, here it is P and this is Q. Suppose that Q coordinates minus A minus B. We know that sum of two sides always greater than the third side, and it is origin. Join OQ, OP and PQ. Now apply triangular property for this. O to P, the distance written as root over x square plus y square. O to Q, the distance is root over a square plus b square. And distance between P and Q, that is root over, using the formula x2 minus x1 whole square plus y2 minus y1 whole square, we get the result. You know that sum of two sides, left hand side, which is always greater than the third side, equality holds whenever collinearity, you know that. So you can easily remember by this method without using all these. Just simply remember sum of two sides always greater than the third side, equality also holds. Just you have to remember in that way. Next, last one, this is to prove this result. I am going to select sum of squares of a minus b, b minus c and c minus a also greater than or equal to 0. This one I am going to select, implies a square plus b square minus 2ab plus b square plus c square minus 2bc plus c square plus a square minus 2ac, which is greater than or equal to 0. Right? Next, I can write 2 times of a square plus b square plus c square, which is greater than or equal to 2 times of ab plus bc plus ca. Neglecting 2 on both the sides. What we get? A square plus B square plus C square, which is greater than or equal to AB plus BC plus CA. In the next step, I am going to write A square plus B square plus C square as A plus B plus C whole square minus 2 times of AB plus BC plus CA I can write, which is greater than or equal to AB plus BC plus CA. Implies you can write A plus B plus C whole square, which is greater than or equal to 3 times of AB plus BC plus CA. Divide both the sides with 9. That is 3 square if you write on both the sides, then you will get that inequality. That is A plus B plus C divided by 3 whole square. Average of ABC, which is always greater than or equal to 1/3 AB plus BC plus CA. This is 5th standard result. I hope you have understood everything. The students, those who are watching my videos, please subscribe ANR Academy channel and don't forget to like, share and comment. Thank you so much.